So we're continuing to look at limiting reactant problems. We visualized it before. Now we're going to take a look at an actual problem for us. So we have 17.82 grams of sodium hydroxide reacting with 15.40 grams of phosphoric acid. How much sodium phosphate can you make? Two things to point out here. How do I recognize this as a limiting and excess problem? Well, I have two amounts of my reactants. If you only have one, the other is in excess. So in this case, we don't have that, so we know it's a limiting reactant problem. Just like before, we need to write out our chemical reaction. So we have sodium hydroxide, which is NaOH, reacting with phosphoric acid, which is H3PO4. We have two given, 17.82 grams of sodium hydroxide and 15.40 grams of H3PO4. So the first thing we need to do is identify the reaction type so we can predict the products. Why don't you try that on your own? So we now have the complete reaction, including balancing it, so we can get started on the stoic part of it. Now, notice in the question it's asking how much sodium phosphate can you make? Sometimes these are multi-part problems, and it asks you later how much of something you can make. So it's good if it's a multi-part problem to take a look at everything to help you decide if there's two products, which one to go for. If it doesn't tell you which product, or if you don't need a product, you just have to pick one. But in this case, we need sodium phosphate. So we're going to do our first stoichiometry problem. I'm going to start with 17.82 grams of sodium hydroxide. So first thing I'm going to go to moles. So grams of sodium hydroxide to moles of sodium hydroxide. Oops. Moles of sodium hydroxide to moles of sodium phosphate. And then moles of sodium phosphate to grams of sodium phosphate. So we can fill in some of our values. Our mole to mole step, so we're going to have a 1 for the sodium phosphate and a 3 for the sodium hydroxide. So this is why you can't look at the masses to just figure out which one's limiting, because usually you aren't given moles, and usually the ratio is going to affect it. The other portion that will affect it is the molar mass, so we need to calculate the molar mass, which is the mm on the PT, for sodium hydroxide and sodium phosphate. So calculate those. So we've calculated, based on sodium hydroxide, that we would make 24.35 grams of sodium phosphate. We are not done, though. We have to do the second reaction. So we have 15.40 grams of phosphoric acid. The nice thing is our last step is going to be identical. So we, just like before, and we have to go from grams of phosphoric acid to moles of phosphoric acid, moles of phosphoric acid to moles of sodium phosphate. Then the last step is identical to the last one. Your last step has to be identical so that you can make a valid comparison. You can't compare two different things in two different units. You have to have the same unit and the same substance in order to make your comparison to determine your limiting reactant. So our mole to mole ratio here is 1 for the phosphoric acid, and 1 for the sodium phosphate. So we just need to calculate then the molar mass of H3PO4 in order to determine what our mass of sodium phosphate will be. So from the phosphoric acid, we end up with 25.76 grams of sodium phosphate. So we have two different amounts of sodium phosphate produced, so we have to make a decision. This is the part about limiting reactants that's a little bit challenging. So what we're going to do, the reactant that produced the least amount of product, which in this case is the sodium hydroxide, is your limiting reactant. So sodium hydroxide is your limiting reactant. This is the amount that you're going to make. You have phosphoric acid in excess. So that's your excess reactant. So this 25.76 is never going to be produced. The most you can make is 24.35 because that's the smaller amount. Well, so we know we've answered the question. We've produced 24.35. Just a word of warning: if you have when you have a limiting reactant problem on a quiz or a test, don't circle both, because that doesn't tell me that you know which one is your limiting reactant. It's a good idea to always kind of write this part out. So write limiting reactant, or LR is sodium hydroxide, ER is H3PO4, just to help clarify your answer. Because if you just circle everything, I don't know that you understand what the process is. I sometimes will even put a little X through this. Not like scribble it out so you can't see it, but put a little X just to make sure that you're clearly understanding the problem. Okay. So we actually have one more part. Sometimes they're going to ask you how much of the excess reactant remains. So what we're going to do is essentially a backwards stoichiometry problem. We're going to find the mass of the excess reactant that was used. So this is based off of this last problem. What we're going to start with is the 24.35 grams of sodium phosphate, because we've determined that that's the amount produced. So 24.35 grams of sodium phosphate is produced. We want to find out the opposite reactant, or the excess reactant, which is H3PO4. We want the mass. So we want the grams of H3PO4. So if you take a look at the last part, we're taking the amount of sodium phosphate that was used, and we're trying to figure out how much phosphoric acid was actually used in the reaction, how much is left over. So we made this much. We want to figure out how much of the the phosphoric acid is used. We know, based on our answers, that a little bit wasn't used. It's probably not going to be a lot. So we're going to do another stoich problem. The nice thing is we've also calculated our molar masses already, so we can just pull those. So we're going to go from grams of sodium phosphate to moles of sodium phosphate, and then moles of sodium phosphate to moles of phosphoric acid. And then we want grams of phosphoric acid, so moles of phosphoric acid on the bottom, grams of phosphoric acid on the top. So we can fill in based off of our previous information. It's a 1-to-1 ratio. Oops. The mass of phosphoric acid is 98.00, and sodium phosphate is 163.94. So you end up with 14.56 grams of phosphoric acid produced. So it specifically asked how much product remains. So we figured out how much was used. We did not figure out how much remains. So we're going to compare. So we had 15.40. And I'm getting that from the original problem. And I'm going to subtract 14.56 from that to figure out how much is left over. So this is why it's important to make sure you read the question carefully to make sure you get the answer that they're asking for. So 8.4 or 0.84 grams of phosphoric acid are left over. You could, if the problem asks for it, you could then calculate how much of the sodium hydroxide you would need to react with that so that you could have a complete reaction. It's a little bit crazy, but you could. In the next problem, it kind of gives us some of the things that we just discussed. So in the problem above, 24.35 grams of sodium phosphate should theoretically be collected at the end of the experiment. So if an experimenter collected 21.50 grams of sodium phosphate, what is the percent error and percent yield? So you want to think of percent yield as like a grade. Percent yield, the higher it is, or the closer to 100, the better your results are. Should say closer to 100. Percent error is how far you want to be close to 0. So based off of this, the value that we calculated in the stoichiometry problem is your theoretical value. So in this problem, they made it pretty explicit. Theoretical is 24.35. Probably, usually it's kind of another part to the problem. You're figuring out the percent yield of something based off of your results. So an experimenter collected this. So sometimes it'll say a student ran this reaction and got this amount, or something else will happen. It doesn't always say experimenter like that. So to calculate percent error, we're going to take the theoretical, which is 24.35, and subtract 21.50. Take the absolute value, divide it by the theoretical, times 100. And then to calculate the percent yield, we're just taking the experimental over the theoretical times 100. I would always encourage you, especially if it asks for both, to do both calculations, because percent error, if you're over 100%, you're not going to necessarily recognize it right away with percent error, but you will with percent yield. Sometimes in an experiment you can end up with over 100%, but usually you do not. So for percent yield, you should end up with 88.30. The sig figs for here are pretty straightforward because you end up with a number, both numbers have 4 sig figs, so your answer should have 4 sig figs. In the one above, you actually have to do 2 things in order to determine sig figs. So you're going to do the subtraction, because addition and subtraction have the rule based on location. So when you subtract, you're going to end up rounding to the 10th place. So you get 2.85. So your answer should have 3 sig figs because of that. Because essentially then what you're doing is taking 2.85 divided by 24.35 times 100. So you end up with 11.7%.